As we start to look at other ways that we can solve quadratic functions, completing the square is the next one we look at. Now what we've looked at so far with factoring is we would have subtracted this 49 over and gotten everything to one side and look at our factoring methods. But we're going to take a different approach here. Let's just look at what we already have on the left side. So I have x squared plus 6x plus 9. This is a perfect square trinomial because x plus 3 quantity squared, or x plus 3 and x plus 3, are the two factors because 3 times 3 is 9 and 3 plus 3 is 6. So it comes out to be this. Now, in the past, we've always had to have a 0 over here, but let's kind of continue on this process. From here, I can take care of these squared by taking the square root of both sides, and that gives me x plus 3 equals plus or minus 49, which gives me x plus 3 equals plus or minus 7. We now subtract 3 over for the both sides, and we get negative 3 plus or minus 7. So our two answers are negative 3 plus 7, negative 3 minus 7, and we get 4 and negative 10. So it's a different method than we've already done so far with factoring, but it still works to get us to our two solutions. And this is involving the idea of completing the square. But what we need to consider is, what if we can't factor? How do we make that perfect square trinomial? And that's really the key we're looking at. So over here I have some rules. So if I have x squared plus bx, I need to add a value to complete the square to make a perfect square trinomial. And what's going to work for us is if we take half of that b value, or b over 2, and square it, it will make a factorable trinomial, which will get to this format that we could then solve by square roots to both sides. So this example doesn't show that process. Let's go to the next screen and use this idea. So first we need to figure out the value that completes the perfect square trinomial. So this is going to be the b value divided by 2 squared. So 50 over 2 squared is going to be 25 squared, or 625. So if I put that in for c, I now have x squared plus 50x plus 625, which factors because 25 times 25 is 625, and 25 plus 25 is 50, to be x plus 25 squared. If we look at the next one, x minus 9x plus c, I'm going to follow the same process and take negative 9 divided by 2 squared. And that gives me 81 over 4. So now we have x squared minus 9x plus 81 over 4. Now it's a fraction, so it's not as nice, but 9 over 2 squared gives you 81 over 4. So 9 over 2 times 9 over 2. And then if I do a negative 9 over 2 plus negative 9 over 2, or think of negative 4.5 and negative 4.5, that adds to be negative 9. So we get x minus 9 over 2 squared is the factored version. The key thing is we're taking this value that's inside the squared, and that's what goes into the binomial, which we have down here. So let's follow that process again. I have to take half of 20 and square it, which gives me 100. So it's going to be x plus 20x plus 100, which half of 20 is 10. It becomes x plus 10 quantity squared. Our next one, we're going to do negative 7 over 2 squared is 49 over 4. So we get x squared minus 7x plus 49 over 4. But that's a perfect square trinomial. We picked that value so that it becomes the negative 7 over 2 inside the binomial squared. So that's the smaller piece to the bigger process of solving. So now let's solve the equation. And this is really where this comes into play, because I cannot multiply to 4 that adds to negative 12. There's not two numbers that do that, so this isn't factorable. So this is our completing the square type of problem. So first thing I'm going to do is I'm going to move the 4 to the other side, because it really doesn't help me what it's currently at. So I'm going to pick a value to put in so that allows me to complete the square. So I'm going to take half of negative 12. Half of negative 12 is 6, negative 6. I'm going to square it, and that's 36. If I add it to one side, I have to add it to the other side, because that keeps a balanced equation. So the left side, x squared minus 12x plus 36, we picked that value because it becomes x minus 6 squared. Negative 6 times negative 6 is 36, and negative 12 is negative 6 plus negative 6. So that's taken care of. The right-hand side is now 32. We solve by square roots. It makes it x minus 6 equals plus or minus the square root of 32. We add 6 over, 6 plus or minus square root of 32. Now the last thing we're going to do here is we have to simplify the square root of 32. Well, 32 is 16 times 2, so that becomes 4 root 2. So our answer is 6 plus or minus 4 root 2. Now, that's an irrational solution. We couldn't have gotten to that by factoring, but now by using completing the square, we can get our answer. For our next problem, I have 2x squared plus 8x plus 14. I'm going to divide everything by 2 to take out the common factor. And by dividing both sides and really all the terms by 2, it really gives us a nicer term and allows us to simplify. So now I have, can I multiply to 7 that adds to 4? And that's not factorable. So we're going to move the 7. We're going to subtract both sides by 7, put it on the other side. I'm going to pick the value that allows me to factor the left-hand side. So I take half of 4, which is 2, and square it to give me 4. If I add it to one side, I add it to the other. From here, we get x plus 2 on the left, quantity squared. On the right, we get negative 3. We take the square root of both sides. X plus 2 equals plus or minus the square root of negative 3. We then subtract the negative 2 from both sides, and your answer is negative 2 plus or minus the square root of negative 3. Now this is not a real solution. It's actually an imaginary solution, which is something we'll look at later. So for right now, we're going to write no real solution. But in a couple videos or in a couple sections, we're actually going to have a way to find the solution. But right now, we're really just talking about real values. Okay, continue on to the next ones. We have x squared minus 10x plus 8. I cannot factor that, so I'm going to put 8 on the other side by subtracting it from both sides. And now I'm going to pick a number that works. So half of negative 10 is negative 5. If I square that, it's positive 25. We're going to add it to both sides. So we get, on the left-hand side, x minus 5 quantity squared, because it's a perfect square trinomial, equals 17. We then take the square root of both sides, and we get x minus 5 equals plus or minus the square root of 17. And by adding 5 over, we get 5 plus or minus the square root of 17. Next problem, I'm going to divide them all by 3 first. I can't factor it, so let's keep x squared plus 4x but add 6 to both sides. We're going to pick the value that works for us. Half of 4 is 2, square that is 4. We add 4 to both sides. That factors the left-hand side to be x plus 2 quantity squared equals 10. The square root of both sides gives us x plus 2 equals plus or minus the square root of 10. And our answer after we subtract 2 from both sides is negative 2 plus or minus the square root of 10. For the next one, x squared plus 10x equals 75. We already have it in the form that we can complete the square. So let's go x squared plus 10x. Half of 10 is 5, squared is 25. We add that to both sides. So we're going to make the left-hand side x plus 5 quantity squared. The right-hand side's 100. We take the square root of both sides. It gives us x plus 5 equals plus or minus the square root of 100, which is x plus 5 equals plus or minus 10. We next are going to go subtract the 5 from both sides. Negative 5 plus or minus 10. So our two answers, negative 5 plus 10 is 5, negative 5 minus 10 is negative 15. Next problem, we already set up in the correct form to complete the square. I'm going to take half of negative 18, which is 9. Once I square that, I get 81. We're going to add 81 to the other side. The left-hand side factors to be y minus 9, quantity squared. The right-hand side is 144. We take the square root of both sides. We get y minus 9 equals plus or minus the square root of 144. we now are going to add the 9 over and then make it plus or minus 12. So 9 plus 12 is 21. 9 minus 12 is negative 3. For our next problem, x squared minus 20x, I'm going to add half of negative 20 is negative 10. That squared is 100. I'm going to add that to both sides. We then have x minus 10, quantity squared, equals 25. We get x minus 10 equals plus or minus the square root of 25 after we take the square root of both sides. This gives us x minus 10 equals plus or minus 5, which becomes x equals 10 plus or minus 5. So our answers, 10 plus 5 is 15, 10 minus 5 is 5. Our last problem here, we have the area of a rectangle is 72. We need to find the value of x once we know the dimensions. So we're going to start with the equation that 3x times x plus 2 equals 72, because base times height gives you the area. This is then 3x squared plus 6x equals 72. After I divide by 3, I get x squared plus 2x equals 24. We're now going to complete the square. X squared plus 2x. I'm going to take half of 2 is 1 and square it is 1. We add that to both sides. So this factors to be x plus 1 quantity squared equals 25. We'll go over here now. We take the square root of both sides. X plus 1 equals plus or minus the square root of 25, which is x plus 1 equals plus or minus 5, or x equals negative 1 plus or minus 5. Now, we want the positive solution here. Negative 1 minus 5 is negative 6, and that doesn't fit the problem if we're looking for dimensions. So we're going to go with negative 1 plus 5 and get an answer of 4 is our value of x.